Welcome to this episode of Superposition Principle, okay, for non-homogeneous second-order differential equation, okay. We're still using undetermined coefficients. I said undetermined coefficient is not the only methods for non-homogeneous second-order differential equation. We can as well use variations of parameters, okay. So it depends on the instruction of the examiners, okay. But shortly, hopefully tomorrow, we'll start our variations of parameters. Hopefully tomorrow, by the grace of God, on Tuesday, we'll start our variations of parameters. But for now, we are still considering the use of undetermined coefficients for solving second-order differential equation. In this question, we want to find the general solution of these non-homogeneous second-order differential equation. Okay, and if you look at these, the non-homogeneous parts, the right-hand side, you see that it has several segments. It has the quadratic segments. It has the e-function segments. Okay, so when you have complex functions at the non-homogeneous parts at the right-hand side, okay, when your f of x, don't forget, your non-homogeneous is this form. In this case now, your f of x now is now containing several functions, maybe f of x, f1 of x, f2 of x, okay, where in this case now your non-homogeneous parts, don't forget your f of x is a non-homogeneous part. Your f of x is a non-homogeneous part. Okay, the homogeneous part is when the differential equation, when your left hand side, that is homogeneous part. Okay, then the non-homogeneous part is this f of x, which is having several functions. Okay, so in that case now we're going to have the solution, the particular solution. We're going to get the particular solution for this one. We're going to get the particular solution for f1 of x, which will be yp1. We're going to get the particular solution for the f of 2, which is yp2. Okay, it could be 2, it could be 3, it could be 4. You do the same thing also for the respective functions. Okay, the f1 of x in this case is quadratic. The second part is e functions. Okay, and each of those functions have their respective rules. Okay, each of them has their respective rules. Without further ado, let's go straight to the solution to this question to see the homogeneous parts and get the what? Get the general solution for the homogeneous parts, and also get the what? The particular solution for the non-homogeneous parts. Okay, and then finally get the general solution for all the solutions. Let's go straight to the work. Get the homogeneous parts. The differential equation equal to 0. That is that, the homogeneous parts. The differential equation equal to 0. That is the homogeneous parts, 0. Step 2. Get the auxiliary equation or characteristic equation of the homogeneous parts. Okay, on here we're going to get the what? YH. For the auxiliary equation, we're going to use this standard equation for auxiliary equation. We're going to use this standard equation where the R is the first differential, the R squared is the second differential. Okay, the attachment to your, look at this, your differential equation. The attachment to your second differential here is 1. Okay, I'm corresponding this differential equation with the standard auxiliary equation. Your A is 1. The attachment to your second differential is A. Okay, and A in this case is what? Is 1. If you correspond it, A is 1, so we have R squared. Okay, your first differential is the R. The attachment to your first differential is the B. And that's minus what? Minus 6 times what? Times R. Okay, and then the coefficient of Y function is what we call the C, and that's what? Plus 9 equal to what? 0. You want. I'm using a factorization method. Pair this one. Okay, factors of 9. I can generate minus 6. That'll be minus 3, minus 3. Okay, and when you multiply these two together, it's going to give you plus 9. So that'll be minus 3, that'll be minus 3. Then this is going to give us R equal to what? 3. Twice, because this is equal to 0, this is equal to 0. Okay, so in that case now, we're going to have, this is what we call the repeated root. This is called the repeated root, and that is the case 2, when your discriminant is equal to 0. So in that case now, we are going to have the one of the solutions, okay, and that will be equal to what? E to the power 3x. Y2 will be equal to what? X times e to the power 3x. All these has been explained in the first lecture of this homogeneous second order differential equation. Solution will now become C1 Y1 plus C2 Y2, which will be equal to, can you make a substitution? So that's a solution for the homogeneous part. How we can get the particular solution? How we can get the particular solution? How do we do that? Okay, what we are going to do, we discuss the superposition principle. Superposition principle is just for us to split these functions into separate functions, get their respective particular solution, and add them together. So we are going to do this. The differential equation equal to what? 6x squared. That's the first splitting. We split the equation into two parts. That's the first one, and this will generate yp1. Send your question. Then the next thing to do is to also do this. Okay, equal to what? The power 4x minus e to power 4x. That's the second one. So that will give me yp2, yp1, yp2. Okay, so we're going to get the solution for the particular solution for the first segment, the solution for the particular solution for the second segment, and they will now add them together. And that's all on superposition principle. When the functions, when your non-homogeneous function is becoming plenty, becoming more than one, okay, that's what we call the superposition principle. Okay, let's now look at the yp1. How can we get yp1? How can we get a particular solution for yp1? If you look at the particular solution for yp1, is of the form of, if you remember what we said, that if your f of x is equal to a x to power maybe m, maybe I said if your f of x is of polynomial of degree n, that's what I said in the rules for undetermined coefficients. If your f of x is of degree n, then your yp also will be of the same form, which is quadratic in nature, and that will be ax squared plus bx plus c. That's the yp1 is of the 6 does not important. What is important is the last polynomial of degree 2. So we need to form a function also of degree 2 of the same degree. Okay, and that's what we have done there. Okay, and in this case now, the auxiliary equation has nothing in correlation with the what? With the YP1. That's nothing. That's no similarity with what? With the f of x. Okay, that's no similarity with the f of x. So that's the YP1. Can we get the first differential? That will be 2ax plus b. That's the first differential. Can we get the second differential of YP1? That will be what? That will be 2a. So that's the first and second differential. Okay, that's the first and second differential. Okay, begin to send your questions. If you're yet to subscribe, please do so right now. If you're yet to subscribe, please do so right now. Begin to share the links across your different platforms. Make it go viral. Okay, share on your Facebook, on your Twitter, on WhatsApp. Begin to do that right now. Okay, so that's what we have now. We've gotten the first differential, second differential of YP1. Okay, so what we're going to do now is to go back to the question and begin to substitute the second differential here, the first differential here. Begin to substitute into the given differential equation. Begin to substitute into the given differential equation. And that will give us the second differential. We have 2a minus 6 times our first differential plus 9 times our y. My y is what? My y is that's the YP1, which is and then equal to what? 6x squared. Subscribe to the channel. Say something. Okay, that is the energy for me. The more you share the links, give me more energy. Equal to 2a. This one times this one, that's 12ax. Minus 6 times b, that's minus 6b, plus 9ax squared. 9 times this one, that's a plus 9bx, plus 9c, plus 9c equal to what? 6x squared. We're going to do something. We're going to arrange the constant terms. We're going to arrange them together, which is 2a. We're going to also arrange the x function. We have here minus 12a. Don't forget the variable x there. This one, this and this. Okay. Then finally the this one, that's 9 plus 9ax squared equal to what? 6x squared. We are going to begin to equate the terms together. We're going to begin to equate the coefficient, equate the terms. I'm going to start with the s squared. Equate s squared in the two sides of the equation. S squared, we have 9a on the left. On the right, we have 6. Equate the terms, 6 over 9, which is what? 2 over 3. Okay, so the weights, the x 10, the coefficient of x here, minus 12a. That's what we have here. Move the minus a to the other side, so the minus I cancel. Equate that. The constant terms, which is 2a, is here. That's the constant terms. We don't have it here. Right hand side. That's a plus 9c equal to 0. Minus 6b, your b is what? 8 over 9. And then plus 9c. Send your questions across your different platform. That's okay. So this will be 3 minus 3 here too. That's a 16 over 3. Okay, plus 9c. Move the 9c to the other side. You got your minus 9c. Okay. So 4 minus 16. That's minus 12 over 3. okay, equal to minus 9c. And this will give me minus 4 equal to minus 9c. So minus cancel. So c is a 4 over 9. C is a 4 over 9. So all the parameters is gotten. Then we can quickly make conclusion for yp1. Yp1 is what? Is a 2 over 3 s squared plus b. My b is what? What our b? 8 over 9 x, and then plus c 4 over 9. So that is the solution for the yp1. That's the yp1. That's a yp1. That's yp1. Okay, that's yp1. Begin to share the links. Share the links. Call your friends. Okay, my friend that want lectures on lines and angle, no problem. Guarantee 100 viewers. Okay, let me know the time you want. Okay, 100 people on your side, just from your own side, minimum. And let me know the time you want. Then I'll make myself available for that. Okay. Begin to share the links across your social media platform. Begin to share the links across your different platform. Begin to share the links. This is live. This is live. You say, is this stream recorded? It's on YouTube now. You can play it anytime. It's on YouTube. It's on YouTube. You can play it anytime you want. You can play it 1 million times. It's left for you. Okay, you can play it 1 million times. It's on YouTube. This video is on YouTube. You can play it at your time, over and over again, over and over again. You can play it as many times as you want. Me too. I'll also go there, play it also, make adjustments. Okay, and I want to say in the next less than 48 hours, the editing will be done for this video. Okay, in less than 48 hours, the editing will be done. All those areas like pause, all those areas I sat down will be removed. Okay, and it will be shorter in terms of our time. So less than 48 hours, the editing will be done. You get to share the links across your social media platform. Share. I said, if you have your question, send the question. Send your questions. Hold your questions. If you have your own questions, send those questions. Send those questions. If you have any questions bothering you on these aspects, either on homogeneous or non-homogeneous, send those questions. And I said that we're going to start variations of parameters hopefully tomorrow. Hopefully tomorrow I will update that on the channel, the timing, okay, for another techniques to solve non-homogeneous differential equations, okay, which is the variations of parameters. There are some functions, there are some f of x which undetermined coefficient cannot solve, okay, and some people feel that undetermined coefficient is Kuhl's sum. They want the variations of parameters. So just relax. On this channel, we're going to do that for you, give it to you, arrange that hopefully tomorrow. Okay, we're going to solve questions that involve variations of parameters to solve non-homogeneous differential equation. Non-homogeneous differential equation. We're going to share the links across a different platform. Share across a different platform. Yeah, you're going to share the links across your different platform. Let's get the yp2. We have the general equation for yp2. We have this equation for yp2. The second differential minus this one plus this is equal to minus e to the power 4x. This is what we're going to use for the yp2. Okay, And then this equation for yp2 will be equal to, the equation for yp2 will be equal to, we have the e function, that will be a times 1 e to the power 4x. We've said in the lecture that if your f of x is e to the power rx, okay, we said that, okay, and it could have a number, doesn't matter, you have 3, you have 4, it doesn't matter, okay. We said the yp will be equal to what? A e to the power rx. I put this one as r subscript 0, okay. Then we now give some conditions. We give some conditions that the condition is that if one of your auxiliary roots, if r1, okay, is equal to this one, if one of the auxiliary roots, if one of the auxiliary roots is equal to the r0, okay, the yp will become what? We're going to multiply this one by what? By the function, because the function is x, okay. You're going to multiply by what? By x. What I mean by that, you can see your f of x, your function, the right hand side is written in form of what? X. Okay, so you multiply that by x. It is written in form of t. Okay, it's going to be what? Everything will be functions of t, and you multiply that by t. If your auxiliary root is repeated root, okay, you're going to multiply this particular one here by what? By x squared. So all these have been explained in this channel. So that's what we have now. Let's quickly make conclusion for the yp. If you check this one, the auxiliary root we had, or we have, r1 equal to r2 is 3 in this case, and the r here is 4, so they are not the same, they are not equal. So this is our yp2. So let's get the first differential for yp2. If you get the first differential, this will be 4 this one, okay. Next session is going on. Let us reduce the bottom there. Okay, so this is what we have now. Then can we get the second differential for this one? Get the second differential. So that will be 16a e to the power 4x. Okay. So we got the first differential, we got the second differential. We just come back here and make our substitution, which will be equal to 16 a e 4x minus 16 minus 6 times our first differential, which is 4. Okay, and then plus 9 times y. My y is what? My y is a e to the power 4x. So you can add everything together. This will be 16 ae 4x minus 24 ae to the power 4x plus 9 ae 4x equal to what? Equal to minus e to the power 4x. Okay, so 16 minus 24, that's minus 8. That's minus 8. Plus 8 plus 9, that's 1. So we have this one minus e to the power 4x. Okay, e to the power 4x. Then this and this we cancel. So a is equal to what? Minus 1. A is minus 1. So that's what we have there. yp2 will be equal to, let's come back here and substitute. That's minus e to the power 4x. So the total yp, total for the particular solution, will be equal to the homogeneous part plus the particular solution, yp total. Okay, so that's that on that question number 1. That's that on that question number 1. The links across the different platforms as are coming in, just begin to say hi. If you are yet to subscribe, please do so right now. Do so right now. Okay, let's go to second question. Question is the same thing also is going to follow the same principle of superposition. Okay, because we have two different functions. We have this is a one f of t, the functions of t, and these are another constants. These are another function. Okay, so these are two different functions, and that will call for the principle of superposition. Get the first particular solution of the first one and the second one and add them together. Okay, step one, get the homogeneous parts, get the auxiliary equation. Okay, and that will be equal to, we're going to use the standard auxiliary equation, which is this, and corresponding with the given differential equation. The attachment to your first differential, when you correspond it, that will be your A. So that will be A, that will be 1 times R squared. The first differential, the attachment to that, that will be your B. That's a plus what? Plus 2 times what? Times R. The coefficient of your Y is the C. C is what? Is 1. Okay? Then you can factorize it or solve it any way you want. Okay, this quadratic equation. Okay. This is the factors of 1 is 1 and 1. That's the only factors. And how do you use 1 and 1 to get plus 2R? That will be plus 1 plus 1. So R is equal to minus 1 because R plus 1 is equal to 0. So that is twice. So this is a repeated root. R equal to minus 1. So this is a repeated root. And in that case, if it's repeated root, it means y1 is equal to e to the power minus x, y2 is equal to x times e to the power minus x. So the general solution for the homogeneous part will be equal to c1 y1 plus c2 y2. Then we can plug in those parameters y1 and y2. We can plug in that, and that will be equal to what? C1 times this one plus C2 times this one. And that's that on the homogeneous parts. Okay? That's that on the homogeneous parts. You get to share the links across your different platform. Share the links across your different platform. The non-homogeneous part is a function of t. So this will be t. Anywhere you see your x, that will be t. That will be t. Okay. Then the yp, to get the yp1, okay, let's get that. We're going to write the differential equation. This one, this will generate yp1. Okay. The second one, do likewise also, plus equal to 3. That will generate yp2. So when you get their solution, then you add them together, and that's just on superposition principle. That's all on superposition principle. yp1. Let's get this the equation for yp1. If you look at this equation, okay, we said in the introduction that if your f of x is this one is of the form of this form. This is of this form. Okay. But in this case now, we're having our function is the functions of t. So I'm going to change the x variable to t. Okay. If your m is 2, this will give you quadratic. If your m is 1, that will be of this form. That will be linear equation. That will be linear equation. This. That's your yp1. Okay. But that's not all. You need to check your R. Is your R, is it a repeated root? Okay. Check your R, your auxiliary equation. Is any one of them equal to the one here? Okay. If one of them is equal to what you have here, then you times it by t. And if your r is a repeated root, that'll be what? T squared. All these have been explained, to us. We've explained all this one. Okay, we've explained all that. Okay. So yp1 will be equal to what? Yp1 will be equal to t squared times the linear equation at plus b, and then don't forget the attachments to that. Okay, because your auxiliary equation is -1. This one also is also what? This is r value. It's also -1. Okay. So can we open the brackets? That will be at cubed plus bt squared times what? E to power minus t. That's the yp1. Okay. Can we get the first differential of this one? Get the first differential. That'll be 3at squared plus 2bt. Okay. We keep this one constant. Okay. Then plus. Now keep this one constant and differentiate e function. And that'll be minus. If you change this one to minus, that'll be minus. We're keeping this one constant. 8t cubed plus bt squared. Okay, times what? E to power minus t. Okay. Because when you differentiate e to power t, it's going to give you the same function. But if you're having -1, okay, let me start from there. When you differentiate e function to give you the same function, but you need to multiply it by the derivative of the power, which is what? 1 in this case. But in our question, we're having -1 d dt of e to power minus t. The derivative of this one, of the power, is minus. So times what? The function itself. Then the second differential, yp2, y prime prime. Okay, differentiate this one. That'll be 6at, okay, plus 2b. Keep your e constant. Keep this one constant. This one, keep it constant. And then plus. Now keep this one constant and differentiate this one. So that will be minus 3at squared plus 2bt e to power minus t. Okay, I'm through with the first segment. Then minus the second one. Open your brackets. Now apply your product rule for this one. Apply the product rule for the second segment. Apply the product rule for the second segment. Apply the product rule for the second segment. Apply the product rule. So I'm just doing the first one. I'm doing this one. The brackets, differentiate that. That'll be 3. That'll be 3 at squared. 3at squared plus 2bt plus 2bt. Okay. Keep the e function constant and then plus. Now differentiate the e function, which will be minus. Okay, and keep this one constant. Keep the this one constant. That's at cubed plus bt squared. Okay, and then e minus t. Don't forget the -1. Okay, and then close the brackets for that one. Okay, so if you open the brackets, the minus will open this one, and the minus will change this one to plus. Change down to plus when you open the brackets. Okay, so that's what we have there. Then let's now go to the function and substitute. Let's go to the function and substitute. We have this one. This is our differential equation. This is our differential equation. Yp second differential plus the 2 y prime plus y equal to t this differential, put it there, which is 6 this. This one and this one, they are the same thing. So it's giving us 2 minus 2 here. We're having 2. This is here. This is here. So that's minus 2 of that function. Okay. Then plus the third one. Okay. Then plus 2 times first differential. Okay. And then plus y. My y is what? My y is what's my y? That's xt cube plus bt squared. Okay. That's my y. That's my y equal to this one. Then we can quickly be making arrangements. This function, check it. That's 2 of that. That's 2 of that, and that's negative. So this one cancel. You open this bracket here, you cancel the first one here. Okay, that's first one. Then another one again. This one and this one, they're the same expression, making 2 of that. And then this one also, this is 2 here. With this one, it's also cancel. This cancel, this cancel. So what left is just 6 AT plus 2b. Okay. E to power minus t equal to this one. Okay, so this one and this one cancel. Then we can have 6 6AT plus 2b equal to t. Okay, that's what we have there. 6AT plus 2b equal to t. Then equate the t 10. Equate the coefficient of t. So if you do that, we're going to have 6a. The coefficient of t on the right hand side is 1. Okay. Coefficient of t on the left is 6a. So a is 1 over 6. A is 1 over 6. For the constant 10, 2b, on the other side, we have 0, 0b. So it's equal to 0. It's equal to 0. So b is 0 in the b is 0. So the yp1 is equal to a is 1 over 6 t squared plus b is 0. Our b is 0, so we can b is 0 e to power minus t. So that, begin to subscribe straight away. Don't waste the time. Begin to subscribe straight away. These are technical questions. These are exercise questions for one of my students somewhere else. Also an exam question somewhere else. Okay, so this is it. For those that are doing this course, they know that this question is very, very important. Okay, so let's get the YP2. YP2, don't forget the differential equation. The differential equation equal to 3. That's what we have there, equal to 3. So that's the YP2. That's for the YP2. Okay, that's for the YP2 plus 3. So YP2 will be equal to what? That's for the second equation. Let me just call it second. That's where we're going to get the YP2. Okay, so YP2 is equal to, this is just a constant and it has no correlation with the auxiliary equation. None of the auxiliary equation is equal to 3. So since the constant, just write, use A, use B. So we can use C for this one. To have equation, this equation, and make your substitution. Second differential is 0. First differential is also 0. 2 times 0. My y is what? That's YP2. That's C. That's 3. So C is what? C is 3. Okay, so the total for the particular solution, yp total is equal to yp1 plus yp2. yp1 plus yp2, and yp1, you have the value as this. Okay, plus what? Plus 3. So that's your yp total. Okay, then the general solution will be equal to yp total plus the homogeneous parts. Just add them together, and that gives you the solution to your answer. That gives you a solution to your answer. Your yp total, we have it here, and then plus the homogeneous parts. The homogeneous parts, we also have it. Just do that, add them together. Okay, just write them to get that. So that will be equal to what? 1/6 t squared times e to power minus t plus 3. The homogeneous part is c1 e to power, what do you get? Is it 3x? Confirm that. 3x t. So that's the general equation. That's the general equation. Okay, that's the general equation. Okay, so that's that across your different platform. Begin to share now. Begin to share the links across your different platform. Share the links across your different platform. Share the links. Share. If you're yet to subscribe, please do so right now. If you're yet to subscribe, please do so. If you're yet to subscribe, please do so now. Share the links even after the online. You can still subscribe. Share. Keep sharing. Okay, give the videos a thumbs up. Okay, you can watch the video as many times as you want. You can watch the video as many times as you want. You can watch it as many times as you want. I appreciate you for coming on board, for liking, for sharing, and for subscribing. If you're yet to do all those 3 ways I mentioned, begin to do that now. Like, share, and subscribe. See you later in the day. See you hopefully today again. Okay, bye for now. Thank you.